Our next speaker is Daniil Lisus, who is a PhD student at the Institute of Aerospace Studies with a talk titled Helping Autonomous Cars See What Our Eyes Can't.
What are the worst driving conditions that you've ever experienced? My worst experience happened during a huge winter snowstorm. I was driving on the highway and the snow was coming down so hard that I couldn't see anything around me. I remember feeling really afraid that I would crash into someone or drive off the road. Thankfully, I made it home safe that day. But according to Transport Canada, up to 20% of fatal car crashes are influenced by bad weather. Now, I work in autonomous driving, and many of you have probably seen impressive videos of autonomous cars driving around California. You might have also seen some frightening clips of those same cars getting into accidents. If you watch enough of these videos, you might notice that the ones showing accidents tend to happen late at night or in bad weather. You might wonder, would autonomous cars be a benefit or a detriment to me getting home safely in a big winter storm? My research goal is to develop autonomous car algorithms that work regardless of the weather conditions. On my slide, you can see what different autonomous car sensors see in both sunny and snowy conditions. Currently, many autonomous cars make use of the LiDAR sensor, which is like the eyes of the car. Unfortunately, just like our eyes, LiDAR can't see through snowflakes, and in a heavy storm can become completely blocked. For the snowy day row on the bottom, we can see that both the camera image in the first column and the red LiDAR points in the second column are affected by the snow. As a result, the radar sensor in the third column has gained popularity. Although radar measures fewer points compared to LiDAR, it's able to see them through the snow. So, with LiDAR, we're very safe in most weather conditions, but can't drive in bad weather. With radar, we can drive in bad weather, but we're not as safe as we could be in most other cases. My research gets the best of both worlds by using sensor fusion, which combines data from two different sensors to improve safety. The challenge for sensor fusion lies in matching data between the sensors. For example, how can we tell that a red LiDAR point and a red radar point come from the same object? To answer this question, I'm using machine learning to tell me which points are easiest to match between the two sensors. Then, I use LiDAR points from clear days and combine them with radar points in all weather conditions. As shown in the last column of my slide, this lets the car see as much information as possible, regardless of the weather. My goal is to make it safer for you to be on the road in a true Canadian winter. Perhaps in the future, when you need to get somewhere during a big winter storm, you can simply sit back and let an autonomous car see what your eyes can't. Thank you.